Problem number 2487, remove nodes from linked list. You are given the head of a linked list. Remove every node which has a node with the greater value anywhere to the right side of it. Return the head of the modified linked list. Remove every node which has a node with a greater value anywhere to the right side of it. Okay, so we will remove the head node, so and we will not have an empty linked list. So we will first have a dummy node. Okay, so if we have 5, for example 1, we have 5, and then the next the length of the nodes is 10 with the power of 5, so we cannot use an n power of 2 method. Yeah, we cannot for loop 2 times unless it's for loop, so it will be, yeah, for 5 I'm thinking of a 2-pointer method, like if we have, if in a normal array, like if we have 5, 2, 13, 3, 8, and how will we do if we need to remove the number that has a number with a greater value anywhere to the right side. So for 5, if brute force method will be, we'll have a pointer. Yeah, we will have right and see if there is a larger value, 13, and we'll delete 5. Oh, maybe we can have a right left pointer, like right, and we will left and right, and the right pointer will try to find a larger value larger than L. So first we will not have, and then we'll move for right, we'll move to 2, and it's not larger, and we'll move to 13. Oh, it's larger, so we will delete L, delete this, and then move on to the next node. next value. Okay, I think, yeah, we should remove yeah, I'm thinking, should we remove all the numbers before R? Because if we did not match, yeah, if we have 5, then we should remove as well. And if we have 8, then we already removed the 5. So yeah, if we find R, then remove all the numbers before R. Then we move on to, yeah, we moved here. And then we will start our next journey for R. And so now we did not meet and then for R, yeah, but we did not delete 3. I have checked the solution, and some of it says we can use a monotonic stack to preserve the maximum and use the maximums to construct a new linked list to return. So I think we will first have an array for, yeah, to extract all the values from the array, from the linked list. So we'll have values, and we will have while current equals head, and while current, we will add the values to the array. And we will use a monostack say max stack, and yeah, we'll have a while and we need 2 pointers starting from leftmost of the array, and then we'll check if our we'll have n equals the length of values, and yeah, we will see if r is smaller than n. Yeah, with a monotonic stack, we will try to check every value in the value array, and if this value is larger than the last, is larger than the elements in the stack, then we should And we should clear the values, the smaller values, and leave the new larger value. And also if yeah, that's it. So okay, if max step if empty or yeah, if values are, I think maybe we don't need L, like if values R is larger, larger to max stack, last one, and then we will push the new values into the stack. And R plus 1. Okay, so, and then we will for loop the values in yeah, we will have a dummy node. Yeah, we will start constructing the nodes in the max stack, and we'll first have a dummy node that will be and the current no yeah, and the current. And for current, we will for loop the values in max stack and current next will be this node with value and Yeah, let's see. So I think I should try run. Like, okay, for here we will get 5, 2, 13, 3, 8, and then well R, we don't need O. We'll have R here. R is smaller than N, correct? Values are will be 5. 5, oh. R is 0, 0, well, yeah, then max stack. Yeah, max stack is having value. Else, yeah. So this now, for now, max stack is empty, and so we'll directly append the first value into the max stack. So we'll have 5. And now R is 1. So we'll move to here. It's 2 now. So those two max stack is having value. So 2, is it larger than? No. So we will append 2. And R will plus 1. R is now 2. So moving here. Okay. So is 13 larger than the rest of max stack? Yes. So that's pop. Okay, is 13, yeah, R is still 2. Is 13 larger than max stack? Yes, so pop. Oh, max stack is empty, so we will not run, and we will append 13 inside, and we will move to R plus 1, 3. And so it's 3 larger, max stack is having a value. It's 3 larger than max stack? No. Okay, so append. R plus 1 is 8 larger than max stack? Yes. So we'll pop. And is 8 larger than max stack? No. Then we'll append 8. R will plus 1, 5, and 5 is out of range. So, okay, we'll finish. We have max stack like this. And okay, so for the values in the max stack, first of all, we'll have 13. So current next will be, we'll have current here. Yeah, nothing. And so we'll have 13, and current next will be 13, and this is none. Okay, and to the next, it's 8, and we'll have, oh yeah, we should move current to current. So we'll move here, and current next will be 8. And current will be 8. Okay, and we have finished, and we will return a dummy. Yeah, so I think return